This REBA-approved CPD seminar offers the opportunity to learn about the fifth elevation of a building and how to maximise the sustainable opportunity that the fifth elevation presents in today's crowded world. So what is the fifth elevation? The roof of the building can be considered as the fifth elevation, after the north, south, east and west. It offers the greatest opportunity to introduce a sustainable and value for money design. So in this seminar, we can show you how to design and enable the roof to work harder. So first, a very brief introduction to SIG Design and Technology. Part of SIG Exteriors Division, we are the specification division of SIG plc, Sheffield Insulation Group, the largest supplier of roofing products in the UK. Based in Leicestershire, with an extensively stocked warehouse in Dudley, we design, supply and guarantee exclusive roofing solutions to meet many challenging specifications. Our technical team works in partnership with specifiers on unique solutions for the job. We choose to supply only the best roof solutions for the project in hand. We have a comprehensive portfolio of sustainable, compatible products selected for their sustainability, longevity, commercial and aesthetic strengths. Roofing systems are installed by members of our Design and Technology Accredited Contractor Group, DATAC for short. Our roofing systems are backed up by SIG plc's own guarantee for complete peace of mind. We aim to leave you with a strategic overview of sustainable roof waterproofing systems and their potential to deliver sustainable architectural design, rules about application and practical examples of best design practice, compliance with manufacturers' requirements, insurance-led norms, and where to seek further advice when asking the roof to work harder. We will also outline briefly what can go wrong with conventional roof design and what we can offer to minimise potential problems and risky design, plus how to rectify and reduce risk to you as designers. And we've seen many a horror story. For example, a very common problem today is damage caused by roof penetrations around supports for photovoltaic and pipe penetrations that have failed, both causing more damage than the value the system offers. First and foremost, the client brief needs developing by asking what use is the roof to be put to. This could include waterproofing, green roof, carbon capture, amenity, energy capture, or rainwater harvesting. The designer needs to understand how to negotiate the compliance minefield. The key to the exercise is waterproofing a roof that remains without penetrations. We are all aware of the compliance minefield. Designing and enabling a sustainable roof to work effectively means that the specifier needs to be knowledgeable on a massive matrix of complex and strategic variables. They include planning points, performance requirements, BREEAM points, BRE ratings, cost, structural requirements, and buildability. So just how can a roof work harder? A comprehensive list of options would include waterproofing, insulation, carbon capture green roofing, energy, drainage, rainwater, living walls, amenity, biodiversity, installation, and roof safety. There are so many options, but it's critical to understand the client brief to maximise what the roof has to offer. The roof's primary function is to keep the water out and the heat in. It's possible to make a sustainable membrane choice that not only keeps the roof watertight, but makes an environmental contribution at the same time. So very briefly, what are the most common forms of single-ply waterproofing? Everyone knows about PVC and the later generations known as TPOs, both of which suffer from not-so-green reputations. But have you heard of PIB? BREEAM, BRE Environmental Assessment Method. It's an assessment method or scoring system to show the environmental performance of a building. Using a PVC can achieve an A rating in a roof build-up, providing the other roof components also meet the requirements. But the rating is made on the system as a whole. PVC could be used in another system build-up which might achieve a lower rating. Polyisobutylene, PIB, is the oldest and still the most sustainable single-ply in the world. Developed back in 1938, it is the only membrane system that offers full life cycle assessment to DIN EN ISO 14040FF. BBA certified, PIB membrane uses the same base polymaterial as chewing gum and surgical dressings. It is also bitumen compatible, therefore it is suitable for over-roofing or new build. So, by the right choice of membrane, you've achieved the sacrosanct goal of roof watertightness and made a sustainable contribution at the same time. Insulation is the major thermal element in roof construction and has impact on specification associated with greening a roof. Government targets on Part L state that by 2016, all new domestic buildings must be zero carbon, and by 2019, all non-domestic buildings must be zero carbon. To ensure compliance with Part L, analysis is taken across the whole roof build-up. The roof has to achieve a maximum U value of 0.2 watts per metre squared Kelvin. With Part L, the issue of thermal bridging for mechanically fixed roofs has been taken out of our hands, avoiding thermal bridging on mechanically fixed roofs. On the left of this slide, and on the previous one, you can see the heat loss on a frosty morning where mechanical fasteners are the method of fixing the membrane. The more heat you retain by reducing thermal bridging, the less energy you use to replace the lost heat. This in turn will lower your carbon footprint and save money as you expend less fuel. You can achieve up to approximately 10% reduction in insulation materials by using thermally broken fasteners instead. These clever devices reduced coal bridging associated with mechanical fasteners that provide direct contact between the inside and outside of a building. Used in retrofit or new build, cut-to-fall insulation is a tapered insulation system designed to ensure good drainage of flat roofs by introducing a slight roof pitch, which is required for flat roofs as stated in BS 6229, Table 6. It should be 1 in 80 for single-ply systems. With tapered insulation, the required fall can be achieved and the necessary thermal insulation is provided in one go. Benefits include quicker to install. Estimated drying out times for screed-to-fall systems are in the region of 100 days, with insulation and waterproofing still to be fixed. Estimated installation times for a tapered insulation system and the waterproofing membrane are between 50 to 150 square metres per day, dependent on deck type and fixing method. Other benefits include reduced weight. Standard sand cement screeds weigh approximately 2,000 kilograms a cubic metre. Tapered insulation systems vary dependent on insulant, e.g. rigid PIR 32 kilograms per cubic metre, rock mineral fibre up to 180 kilograms per cubic metre. Hence, tapered insulation offers a huge benefit in the reduced additional weight added to the structure. More suitable for complex fall configurations. Timber furrings can be complex to install when crossfalls are required. There is also the potential for condensation risk within voids formed by the furrings. Insulation values differ from one manufacturer to the next, and the thickness of insulation depends on the build-up for the roof. But as a rule of thumb, the thermal conductivity of rigid polyisocyanurate foam is usually within the range of 0.025 to 0.023, and rock mineral fibre has a thermal conductivity of 0.035 to 0.045, but this value varies depending on the density of the material. Specifying a green roof makes perfect sense. It makes good use of space and optimises the structural footprint of a building. The green roof captures carbon. It improves air quality by absorbing airborne pollutants through plants, removing them from the environment. A green roof also substantially increases the life expectancy of the roof's waterproofing membrane as it protects it from UV degradation and extremes of climatic condition. It assists urban drainage. It provides thermal and acoustic insulation. It provides an additional green space for wildlife. And of course, a green roof is aesthetically pleasing. Green roof membranes require FLL certification. There are 2 levels, for root and rhizome protection.